Acid, you end up producing carbon dioxide, H2O, and the salt of the metal. Is that okay?
Yes.
Okay. Now, having written the equation, step 2, balance the equation. Balance the reaction. So how do we balance the reaction? Once again, we can see Ca here, C here, O here, H here, Cl here. The same thing here, C, A, C, O, H, Cl. Now let's balance it. There's one Ca here, okay, and there's one Ca on the right. So Ca is balanced. For C, there's one C here. There's another C1 over here. Then for O, there are 3 oxygen atoms on the left. Do we all agree?
Yes.
On the right, 2 plus 1, 3. Then H is only 1 on the left, but on the right, the H, 2. Okay, there are 2 there. And finally, the chlorine, 1 on the left. On the right side, there are 2. So it means the hydrogen and the chlorine are not balanced. So we have to balance the H and the Cl. Okay, so what do we do? Since 1 hydrogen is on the left, but 2 on the right, what do we do?
Just add a factor of 2.
So we put a factor of 2 here to the HCl, and the equation is balanced. Is that okay? What this means is that for every 1 mole of calcium carbonate that reacts, it requires 2 moles for the reaction to go to completion. Is that okay? Alright, let's continue. Now we have been asked to calculate the amount of the acid that reacted. The amount of the acid that reacted. So let's see how it goes. The first thing to do is to calculate the number of moles of the calcium carbonate. Is that okay? Because the question gave us the mass of calcium carbonate to be 40 grams. We know the mole ratio is 1:2, but we don't know the number of moles of the calcium carbonate that reacted. So we cannot also know the number of moles of the HCl until we calculate the number of moles of the calcium carbonate. So the first thing to do is calculate the number of moles of calcium carbonate in the 40 grams. How do you do that? First thing, you find the molar mass of the calcium carbonate. Good. So let's all calculate. Find the molar mass of the calcium carbonate. Good. Calcium is 40. Can you see that? Plus carbon, which is 12.0. Then oxygen. How many oxygen atoms? There are 3 oxygen atoms. So each oxygen atom is 16 times 3. So you're going to have plus 3 times 16. When we do our calculation, we'll end up with 100 grams per mole. So now we know the number of the grams of calcium carbonate present in 1 mole. So we can calculate if every mole of calcium carbonate contains 100 grams, then how many moles will be present in 40 grams? You understand? Okay, so let's do our calculation. So 100 So let's calculate. 100 grams is found in 1 mole. So 40 grams, how many moles will be 40 grams? It's going to be less, right? Yes. So if less, more divide. So you're going to have 40 grams. The x will be equal to 40 grams over 100 grams times 1 mole. This will cancel this. This will go out. So you end up with 0.4 mole. So 0.4 mole. That is the number of moles of the calcium carbonate present in the 40 grams. And that is what reacted with the HCl. So now that we know the number of moles, in actual fact, if we use the other formula, N equals mass over molar mass. The mass was given to be 40 grams. The molar mass was given to be 100 grams per mole. And so you end up with 0.4 mole. Is that okay? So you can use any of the two. Now we know the number of moles of the calcium carbonate. We're using mole ratio to calculate the number of moles of the HCl that reacted. Is that okay? Can we go on? Yes. What is the number of moles of, what's the mole ratio between the calcium carbonate and the HCl? 1:2. So we calculated for the number of moles of the calcium carbonate because 0.4 mole. But for the HCl we don't know, so we go ahead to calculate. When you do your, it's going to be X equals 2 times 0.4 mole, which gives you 0.8 mole. Therefore, amount of HCl equals 0.4 mole. Sorry, 0.8 mole. Is it easy? Yes. Very simple. So that's the amount of the HCl that reacted with the calcium carbonate. Very simple. Make sure that you calculate the number of moles of the calcium carbonate. They use the mole ratio between the calcium carbonate and the HCl and calculate for the number of moles of the HCl. We got this. If the question had continued and said, what is the mass of HCl that reacted with calcium carbonate? What would have been the solution? How would you go about it? Yes.
Amount of substance is equal to mass over molar mass. So you find the molar mass of the you change your subject.
Good. So since we know the number of moles of the HCl to be 0.8, to find the mass is easy. Just calculate the molar mass of the HCl. So we calculate the molar mass of the HCl, and then we get hydrogen is 1, chlorine is 35.5. So you end up with 36.5 grams per mole. Having calculated the molar mass of the HCl, we go ahead and use our formula N equals mass over molar mass, and that helps us to calculate the mass of the HCl. So the mass is what we are looking for. So this implies that mass equals N times molar mass. The amount of substance was 0.8 mole, and the molar mass is 36.5 gram per mole. So when you calculate, what will be your final answer? 29.2 grams. Okay. Any question? Any question? Any question? No question? You understand fully what is happening? Okay. We'll look at one last question for today in the application of mole ratios. Look at our third question. Our third example, aluminium reacts with hydrochloric acid to evolve hydrogen gas. Aluminium reacts with hydrochloric acid to evolve hydrogen gas. Write a balanced equation to illustrate the reaction. I ask, if 2.27 grams of aluminium, if 2.27 grams of aluminium reacts with excess HCl, calculate the mass of hydrogen obtained. So that is the question. Al equals 27.0, hydrogen equals 1.0, Cl equals 35.5. Yeah. So that is the next example we have to look at. Aluminium reacts with hydrochloric acid to evolve hydrogen gas. Write a balanced equation to illustrate the reaction. So the first thing for us to do is to write the balanced equation. Now, when aluminium is a metal, is that not it? And hydrochloric acid, of course, is an acid. So when a metal reacts with an acid, what are the products expected? Salt and hydrogen gas. So that is good. The question gave you one of the products. so you provide the other product. So Al solid plus HCl reacts to produce hydrogen gas and aluminium chloride. I hope we all understand. So now that we have Al, HCl, hydrogen gas, and aluminium chloride, what is the next thing to do? Is to balance the equation. So now let's balance it so fast. Who can tell me what to place what? Yes. 3 to the HCl. Wow.
And then this we add 1.5.
Okay. Multiply through with a factor so that we don't have it. Yes. 2 here. 6 here. 2 here. 3, okay. And 2 here. That is correct. Everything is balanced now. Okay. 2Al plus 6 HCl producing 3 hydrogen gas and then 2 moles of aluminium chloride. Okay. So now that we have balanced the equation, the next thing is to calculate. If 2.27 gram of aluminium reacts with excess HCl, calculate the mass of hydrogen gas obtained. They are asking us to calculate the mass of hydrogen that was obtained. Is that not it? So first thing is, well, we've been given the mass of aluminium. The mass is 2.27 grams. What to do is calculate the number of moles of the aluminium in the 2.27 grams. Then use mole ratio. Step 2. Use the mole ratio between the aluminium and the hydrogen gas to find the number of moles of the hydrogen gas that was produced. After finding the number of moles, step 3. Calculate the molar mass of the hydrogen gas, multiply it with the number of moles of the hydrogen gas, and you get the mass of the H2 that was produced. Is that okay? Do you understand the steps? Step 1. Calculate the number of moles of aluminium in 2.27 grams. Step 2. Use the mole ratio between aluminium and hydrogen gas to find the number of moles of the hydrogen gas. Step 3. Having gotten the number of moles, find the molar mass of the hydrogen gas and multiply it with the number of moles to get the mass in grams of the hydrogen. Is that okay? So let's go about it. So first things first, let's take the number of moles of aluminium is going to be 2.27 grams over the molar mass of aluminium. In fact, here it is relative atomic mass, which is 27. Okay, so because of this, now when you calculate this, what will be your answer? What was your answer? 0.084 moles. Okay, Now we have our number of moles. Then the next thing to do, mole ratio between aluminium and hydrogen gas. Can we do that?
Yes.
Okay, so the number of moles between Al and H2. The mole ratio is going to be 2 is to what? 3. 2 is to 3. Okay. But we know the number of moles of the aluminium to be 0.084. But we don't know that of the hydrogen. So we can now solve. This implies that 2 times x equals 3 times 0.084. That implies that x equals 3 times 0.084 over 2. And you do your calculation. What is the answer? 0.126 mole. That is good. Having gotten 0.126, now we know the number of moles of the hydrogen. So what do we do next? Find the molar mass of the hydrogen. Now, the molar mass of the H2 is 1.0 times 2. And that gives you 2 grams per mole. Having gotten the molar mass, N equals mass over molar mass. This implies the mass is amount of substance times mole. The N, which is the amount of substance, is 0.126 times the molar mass, which is 2. So you end up with, when you multiply, what will be the final answer? 0.252 grams. 0.252 grams. This is just one way of solving this question. The other way is to use the masses straight away without going through the calculation of the number of moles. You can just use the mass to do the calculation. Any question? Yeah, I'm done. Okay, so let me round up. Okay. Now, so today once again we looked at application of mole ratio in solving questions. And the first question was the reaction between hydrogen and hydrogen peroxide. Then the next question we looked at was the reaction between calcium carbonate and hydrochloric acid. And finally we looked at the question where we saw aluminium reacting with HCl to produce hydrogen gas and aluminium 3 chloride. Now we saw how to use the mole ratios to help us to get the number of moles of other substances which we have not been given any information about. And then having solved, we were able to use the number of moles to now go ahead and calculate the mass of the substances involved in the reaction. I hope this has been a very good study. Thank you.